I'm going to talk you through the questions on 27.3, fission and fusion. So, question 1 says, explain why the protons in a nucleus do not leave the nucleus even though they repel each other. You need to say that the strong nuclear force is large enough to overcome the electrostatic repulsion. And it says 1b, explain why the mass of the nucleus is less than the mass of the separated protons and neutrons for which the nucleus is composed. So you need to say that the strong force does work to create the nucleus, and therefore you need to do work to separate the nucleus. And that energy, the amount of energy required to do that is equal to the change in mass according to Einstein's theory, E equals mc squared, where energy and mass are equivalent to each other. Part 2a says what's meant by nuclear fusion. So you need to say that it's the splitting of a large nucleus, and you must say the word nucleus, into 2 smaller nuclei, which will increase the binding energy per nucleon. And B, part 1, the incomplete equation below represents a reaction that takes place when a neutron collides with the nucleus of a uranium isotope. Determine the values of A and B in this equation. So you've got the equation. Here. So we're going to figure out the top number first. So we're going to find B first. So 235 plus 1 minus 136 plus, we've got 2 1s here. Put that in brackets. So you should get an answer there of 98. So B is 98. So 136 plus 98 plus 2 makes 236. Then to find A, you've got 92 plus 0 minus A, 36 plus 0, because there's none there. Excuse me. Which equals 56. So A is 56. Okay. Then for B part 2, it says calculate the energy in mega electron volts released in this fission reaction, and it gives you various masses. So the change in mass is going to be what you had before, so 234.993 plus 1.00867, so that's the masses of the uranium and the neutron. And then you're going to take away the masses of the xenon plus the krypton plus 2 neutrons. Obviously you can sort of cancel these out, so that will cancel with one of those and you only get left with one of those there, but if you're not sure, do it all in one go. Gives you a change in mass of 0.22133 U. So that gives you a change in energy of 0.22133 times 931.3, which is 206.124.629, which is 206 mega electron volts. Okay. Question 3. What is meant by nuclear fusion? So you need to say it's the joining together of 2 small nuclei to form a larger nucleus, thus increasing the binding energy per nucleon. And then it also says hydrogen nuclei to get fused together to form helium nuclei in the Sun. The 2 stages in this process are represented by the following equations. Describe the reactions that these equations represent. I'm not really sure what that question means, so I've just written that in the first one, 2 helium nuclei join together to form a 2,1 helium nucleus with a release of a beta plus decay to, beta plus particle to conserve charge, and also they missed off a neutrino there, so there's also a neutrino release to conserve lepton number. And in the second reaction, I've just said 2,1 hydrogen joins with a 1,1 hydrogen to produce an helium isotope. I really don't know what they want from that question. The next part of the question says calculate the energy released in each reaction. So we can do that. So reaction 1 is here. This has no mass. So that's your neutrino. So the change in mass has got what you're going to have before. So you've got 2 protons. Take away what you've got after. So these values are all given to you in the book, which gives you a change in mass of 4.6 times 10 to the minus 4u, and therefore a change in energy times that by 931.3 of 0.43 mega electron volts. And part 2, the equation is 2,1 hydrogen plus 1,1 proton goes to a 3,2 helium. So the change in mass is going to be what you had before. Those values are given to you. So that's the heavy hydrogen and the proton, which is just the hydrogen nucleus, minus the mass of the isotope of helium. So that gives you a change in mass of 5.9 times 10 to the minus 3u. And you can work out the change in energy of that is therefore 5.9 times 10 to the minus 3 times 931.3, which makes 5.5 mega electron volts. Okay. Part 4 asks you to explain why light nuclei do not fuse when they collide unless they're moving with sufficiently high speed. You need to talk about the fact that there's electrostatic repulsion, so the light nuclei need to have enough energy to overcome that to get close enough for the strong force to take over, so within 4 femtometers. Okay, part B asks you to calculate the energy released in the following reaction. This is actually the last reaction in the, it's called the PP chain. It's the last fusion reaction in the Sun. You've just done the other 2. So the change in mass is what you had before. So you've got 2 of these. It tells you their mass in the information. 3.01493, and you're going to take away the mass of the helium plus the mass of 2 protons. That gives you a change in mass of 0.0138u, which gives you a change in energy of 12.85194, so 13 mega electron volts to 2 significant figures. Okay, hope that helps.